All right, so let me, we're going to shift to Dr. Milewski's panel right now. Thanks, Ben. You're looking good there in those ODUs. Good for you. I want to just make sure before I jump the gun that the good doctor is with us. Okay, great. So I will just do a quick introduction of Dr. Milewski, who may need really no introduction, but as a tenured professor of maritime business admin and marine science, and she's actually the head of the maritime business admin department at Texas A&M, University of Galveston. So it's great to have you, and I know I will let you introduce your panelists, but I did want to answer a question. These sessions are indeed recorded, and I'll let Andrea or Katie address those more thoroughly, but they are recorded for posterity. I'm really excited to hear what your panel, Doctor, has to offer. And without further ado, I think I'll turn it over to you so that you can potentially make some comments before we start the presentation of your recorded panel, before you go into Q&A.
Okay. I'm Joan Milewski. I'm from Texas A&M University at Galveston. We are the C branch portion of Texas A&M, and we have the Texas A&M Maritime Academy on our campus as well. We are going to talk today about resilience in the maritime supply chain. We have several. Resilience, as you know, is the science of preparing for, dealing with, and recuperating from some sort of shock to the system. And so, and how fast you recover is really the essence of the question. We have 5 panelists besides myself. I come from, I do a lot of research in maritime business and maritime security. And my Fulbright was at World Maritime University in maritime security. So we have Dr. Galvao, who she's been recorded. She's in class, so she won't be joining us till a little bit later, but her recording will be here. Her area is port governance and how that can contribute to resilience. Dr. Amir Garagazli, he's from California State University. He's an engineer as well as a PhD in management, and he will talk about how well that the maritime supply chain does from an operations management perspective. Dr. Paul Kula, who's a professor of the practice for Ocean Engineering Department, he's going to look at the hard systems of cybersecurity and resilience of the chain. We are also going to hear from Colonel Len Waterworth, who's an executive professor, and he was the associate director for outreach on Centers for Beaches and Shores, looks at flooding and how flooding can hurt resilience. He is also the former head of the Port of Houston Authority. And then finally, we will hear from Professor Paula DeWitt, and she is a computer science and engineering at here and in College Station. She is building our maritime cybersecurity program, and she is a computer science PhD, but she's also a lawyer, and so she has her. She's also good at math. She's kind of amazing. And so she will talk mostly about the cybersecurity stuff. Okay, so I guess with further ado, you will play the recordings, and then we'll be here for questions. Okay. Welcome to this panel, which is the resilience of the maritime supply chain. Resilience, as you know, is the science of preparing for, dealing with, and recuperating from shocks. So we will be discussing those. First, let me introduce the members of the panel. First off, we have Len Waterworth, who is an executive professor in the Department of Maritime Administration. He is also the Associate Director for Outreach in the Center for Texas Beaches and Shores. What Colonel Waterworth, as he was known in his long career with the U.S. Army Corps of Engineers, he was also the head of the Port of Houston. Now, Paula DeWitt is an associate professor of the practice in computer science and engineering at Texas A&M and in the Maritime Business Administration Department. She is currently the head of our Maritime Cybersecurity Program, and she will discuss that during the panel. Cassia Galveo is an assistant professor, and she is currently in also the Department of Maritime Business. Her area of expertise, as she will talk today, is corporate governance as it relates to ports. She also works on port reform and many other topics in the maritime. She's well published. Finally, we also have, Amir Garagazli. He is an industrial engineer, and he is at the California State University at Norridge in the Department of Systems and Operations Management. His work has applied to algorithms as they look at the efficiencies in the ports. He's basically a logistician, and he is also well published. Finally, Paul Kula. He is a professor of the practice at the Ocean Engineering Department at Texas A&M University. He is also versed in cybersecurity. He will look at the resilience from an engineering standpoint during this discussion. I am Joan Molesky. I am the head of the Maritime Business Administration Department, and I am a tenured professor at Texas A&M University. So I will let you now start with Len Waterworth.
All right. Hey, thank you very much. I'm Len Waterworth, and thank you very much, Joan, for the introduction. As I started to prepare for this presentation, it just dawned on me. I've been in the Texas area for over 20 years here. The Army brought me here to Galveston to work on environmental restoration projects, flood damage reduction, and what I found the most interesting is navigation and the widening and deepening of the Houston-Galveston Ship Channel. Well, at the end of my tenure, I had the opportunity to go back to Washington, D.C. or stay here in Texas, and I realized I wanted to stay in Texas because it was an economic engine. And I started to realize that Texas was the #1 exporting port in the nation. And this region of Houston is the #1 region in the United States for for exports. And the port itself, which I had the opportunity to be the executive director, and it's 200 businesses, is #1 port for foreign tonnage. And you start to put all that together. Oh, and the energy capital of the world, the largest petrochemical complex in the United States, all sitting on 52 miles of ship channel with 200 businesses. You know, it's generating about 3.2 million jobs and generates nationally over $800 billion worth of economic activity. So this is an economic driver. And what's really interesting about the whole process, this economic engine is driven by about 10,000 deep water ships and over 200,000 barges. So not only is that amazing, but it sits on Galveston Bay, which is the second most productive estuary in the United States. And it's the fourth largest city with 6.5 million people sitting in the 10-county area. But this is about risk mitigation to the maritime business, black swan events. And we do have risks right here in this area. We have risk from floods, from hurricane surge, rainfall, and we have been hit before. We've had black swan events. The storm of 1900 that killed over 6,000 people essentially took the premier city with a premier port in Texas and moved it 52 miles inland after the storm of 1900. We've had other great black swan events. One that comes to mind right now is Harvey, with over 50 inches of rainfall in about a 72-hour period. So we have events. So the question becomes, what do we do? Well, we know from historical averages that we're going to see a Cat 3, 4, or 5 hurricane every 12 to 13 years. Oh, and by the way, we have a Cat 4 hurricane in the Gulf right now, headed towards us. Hopefully it curves off, and I hope it doesn't bring too much danger to our neighbors in Louisiana. But one of the black swan events that we did miss that caused the Texas A&M Galveston campus to start thinking about resiliency is the storm of Hurricane Ike in September of 2008. And it caught our attention because 6 hours before the storm was going to hit, it was forecasted to go right up the Houston Galveston ship channel. There were predictions that woke up the governor that evening that there would be a 27-foot surge expected in downtown Houston, 52 miles away from the entrance of the channel. So at that point, we start to think it was going to be one of these big events that would have a historical shift, just like the premier port in Texas in 1900, moving from the coastline 50 miles inland. But veered off at the last minute, and we had essentially an event that only cost the nation about $30 billion. But it was that point in November of 2008 that we had professors here on the island started thinking about how do you mitigate, how do you build resiliency into this region that is an economic engine, and the concept of the Ike Dike. Professors on campus started thinking about actual structures, environmental changes, the business ramifications, and how to build resiliency, because the idea of actually moving 6.5 million people and moving the largest petrochemical complex in the United States seemed to be a bigger task than trying to build resiliency. So it's that point that the concept of the Ike Dike was born. Ike Dike, if you're familiar with the Galveston area, the response to the 1900 storm was a seawall. Ike Dike was going to be an extension of the seawall, but built with new technologies. The berm itself was going to be sand, but the premier feature was going to be gates across Bolivar Roads. And Bolivar Roads is a narrow passageway that it crosses from the Gulf of Mexico into Galveston Bay. And at that point, large gates were foreseen in 2008 that would hold back storm surge, not allowing the water in the bay to increase, because that was where danger came from when the water in the bay went from 12 feet to 20 feet, and that got pushed around by the wind. So that was the concept. Started in November of 2008, right here on the Galveston campus, which sits on the mouth of Bolivar Roads, right at the intersection of the bay and the Gulf of Mexico. And the question is, that was where the idea is, and where are we today? Well, very fortunately, it's taken this amount of time, but working through local governments, working through the states, working through the federal process, working with the Corps of Engineers. The Corps of Engineers essentially started a study of the entire Texas coastline. And what has happened is that they will come out with a report that essentially adopts the Ike Dike, the coastal spine, and gates across Bolivar Roads as the federally preferred plan. And we should see a final report go to the chief of engineers and hopefully off to Congress by the middle of next year. But the whole idea stemmed here in an academic environment to change the process, speed the process up to help build resiliency, to help protect not only 6.5 million people, not only in the environment, but the maritime logistics chain of the busiest port in the United States. So I'm looking forward to your questions, and I'll turn this back over to Joan.
Howdy, as we say in Aggie Land, and thank you for inviting me to be part of this panel. My topic today is on cybersecurity resiliency. I want to thank Glenn for giving an introduction on the great statistics on the port. However, he was talking about black swan events, usually weather related. So imagine an event that the weather is great, everything looks good, we have no warnings, but we're hit by a cyber attack. The same consequences can happen. It's a black swan event, which means it has a low probability of occurring, but the consequences can be disastrous. Building on Lynn's comment, let's look at the criticality of the Houston port. What happens when it's crippled by a cyber attack, and how could this happen? You could attack the automated ships, the vessels. You could attack the port operations itself. You could attack the supply chain. Cyber resiliency is a concept that we've used quite a bit in other areas that is just now gaining traction in maritime. And what it basically means is this: can we keep the systems operational while under a cyber attack? A good lesson is occurring now. The CMA CGM company, a French company, was attacked last week by ransomware. They are not yet up to full capacity. It was an attack on their information technology systems, that is their IT systems. The ransomware locked up their systems on their scheduling. So they can't schedule, they can't track containers, they can't figure out what's going on. The attack, interestingly enough, occurred on their ships that were in 4 Chinese ports. That's an IT attack, information technology. But in the maritime system and environment is highly automated. And by that, we call that operational technology. It's the best way to think of it, operational technology, highly automated. And our systems are highly automated, and they're becoming more automated. And yet we've overlooked this concept of cyber resiliency. But it's an easy concept to think about. It's just very complex to actually execute. Can we maintain the operation of cyber physical systems so that they continue to operate while the systems are under cyber attack? Now, first of all, you have to understand what cyber physical systems are. Every single computer system has physical components, right? We have our laptop, our keyboard, our hard drive, all the internals. That's not a cyber physical system. A cyber physical system is a system where the software, the system itself, manipulates the physical systems. So for instance, it turns on valves, it turns off valves, it has sensors, and it's the basis of the highly automated system. In cybersecurity, we protect, detect, defend, and recover. And these operations are different in your OT, highly automated systems. We can't protect them the same way we protect IT. We can't detect, we can't respond, we can't recover. Everything is different in that environment. So why are these attacks happening? Well, first of all, the maritime environment is a highly valued critical infrastructure. These attacks are occurring by both criminal and nation-state attackers. Criminals are after the money, ransomware. Put so much Bitcoin in, and I'll give you the code to unencrypt the systems that I have now encrypted. Nation-state attackers are after our national security, our economy, the health, safety, and well-being of the nation. This is part of our critical infrastructure's protection with the U.S. government. And there's so many diverse stakeholders within the maritime system, different vendors, different companies. It's highly complex, and they have various levels of cybersecurity sophistication. But we do know this: we're seeing an increasing attacks on the maritime transportation system with the same possible consequences as Lynn talked about that can cripple our ports, cripple our economy, cause us to be dead in our tracks. I'd like to close with this thought. This is a disturbing pattern. If you look at the attack on the CMA CGM, you will realize that all 4 major international shipping companies have been the victims of ransomware attacks in the last few years. Maersk came within completely being wiped out in 2017 if it were not for a power failure in Ghana that prevented that system owned by Maersk of downloading NotPetya. And I should say this was not a targeted attack. It was an accident. NotPetya was a ransomware that the Russians were putting on the Ukrainian systems, and it got out in what we call in the wild and somehow got onto Maersk. And it was disastrous. They came within 5 days of completely losing operations. So I'd like to close with that and these salient points. We are becoming a target. We have to put in the protections that we have. These are big, well-funded nation-state attacks or criminal attacks. And this is important to keeping our health, safety, and well-being of our national and international economies. Thank you for your time.
All right. Hello, everyone. Thank you very much, Dr. Molesky and the organizing team for inviting me to participate in this panel. My talking point, more than actually a discussion, is going to be about governance and resilience and port governance. So what I have thought about this brief discussion we are working on here is actually to structure it with 3 questions, kind of like what we want to know, what are the relationships we're looking at when we think about governance and resilience. I am happy to be the 3rd speaker so that it saves me time in explaining what resilience is, and Len and Paula did a great job in doing this, and of course Dr. Molesky in her introduction. But basically I want to show you a few diagrams that is going to, first of all, give us an overview, an overall idea, what are the governance dynamics that we are dealing with when talking about ports. It is obviously, it borrows a lot from the traditional, or let's say, any type of business governance models, but there are some particulars associated with ports that I want to highlight to you. And of course, how the resilience is measured and what is the relationship between these 2 sets of frameworks. So the first thing I want to just recap, obviously, we are in the research and business, or if you are coming from a, experience working for the industry, we know that governance is about the way rules are formed, the way they are enforced, and the way they influence the decision making, and people are held accountable. That's the general framework we see about governance. And governance is doing its job, is doing these 3 things. I know, and we might also want to take a look on this in the discussion time of this panel. There is a trend nowadays to discuss what good governance would look like, because one thing is to have a governance system, and the other thing would be to have a good governance, what good governance would mean. I'll leave that to the discussion for right now. I just wanted to bring it up and say, well, when we apply this generic governance framework to ports, we necessarily have to deal with these 3 boxes you see here on the right-hand side, which means that there is going to be always a degree of interaction between public and private actors or participants because of the nature, the way ports are established, right? The nature of the physical infrastructure, the way operations are done, labor is hired, and of course, the cargo owners or the beneficial cargo owners, also known as BCOs. So with this table, it tells us here, I'm going to read it for you. Obviously, I just want to highlight the idea that it's going to be always a degree of interaction, and I would say of conflict between these 2 public and private actors. So that adds up to the governance, to the whole idea of rule setting, holding people accountable. There's going to be some level of complexity, an increasing level of complexity because of that. In addition to all the complexity that Dr. DeWitt just emphasized with the critical infrastructure as ports are. So what happens is in the discussion of governance, and I know this chart is quite overwhelming. Don't freak out for now. I'm going to go slow through this explanation. This is coming actually from this group of researchers here, Dr. Mary Brooks and Dr. Pallis. They have a group of researchers that investigate governance, port governance in the last 20 years, and I was part of one of their publications. So, and what we have noticed over time is there was an increasing need for changing port governance, or adapting or modifying or introducing new regulations were introduced despite the port organization or how well it was performing. So we initially started studying, that's the first part you see here on this diagram. There was the idea of a pre-reform situation. So, and what happened when the reform was introduced? This has to do with all this, dotted arrows here. New regulations were introduced. And so the process, let's put it this way, cargo is a cargo, a ship is a ship, and the whole idea is that ports are supposed to be working as a point of exchange, right? The efficiency or the job of a port is basically to move cargo as fast, as cheap, as efficient as possible. So additional regulations in a highly regulated industry sometimes brings impact to these efficiency levels. This is how port performances start being strongly linked, or let's say highly correlated, to efficiency and effectiveness. So what this diagram is telling us is basically that there were waves of reforms, and every time a new regulation, a new set of rules, a new law was passed, a new regulatory body was created, the port actors, or the whole port governance changed, and so it impacted operations again. So what it has to do with the real business, say we are trying to make things better from the governance perspective, hold people accountable, improve or make the decision process more transparent to all the stakeholders involved. And we have a lot of more stakeholders nowadays as we used to have in the past, or at least their influence is stronger nowadays than it was in the past. So this is the idea that they start saying there is a generation of governance adjustments. It became, to a certain extent, a permanent job in the port governance structure to deal with these new regulations. One thing was to just, there is a new law, these are the new things we have to do, or the new regulatory issues that we have to comply with, and that's it. You adjust your systems and you move along your operations. Now it became more like almost like a yearly, it became obviously part of their strategic planning. And as part of the strategic planning, say what is going to be the next thing that they're going to change. So, and in order to assess that's my next diagram here, and I'm moving towards the end of this brief discussion here, is a map. This one was made for the UK ports, but essentially it's very comprehensive. This is why I'm using here as an illustration. You cannot really manage what you cannot measure, right? Everybody knows this, kind of like a mantra from management. And what these colleagues here have done, they put it in a spine, in a fish spine type of diagram here. Well, if operations and port performance is highly depending on how well you operate, obviously the financial side is another way how to measure performance as well. But if we're talking about the operations itself, that's the box here, the disruption, right? We have to take into consideration everything that might happen, kind of like mapping all your risks or your vulnerabilities before you can actually take precautions or be able to protect and detect, as Dr. DeWitt was telling us. So, and you can see here, they have a little bit of everything. They have the cyber over here, there's epidemics on here, but there's a ton of other factors affecting this. So, and now it becomes the question, so if this is the reality, so this is all the factors that we should be resilient, we're looking for having ways how to be able to recover, right, from a disruption, man-made, natural-made, whatever the circumstances bring about. So what is the role of governance? What is the role of setting the rules or having a concrete and determined set of rules and authority to make decisions in a situation like this? So my takeaway message is obviously comes from this famous diagram. Resilience is essentially measured by time. How fast can you go back to your normal operations after some disruption happened? So, and to answer the original question I had here, so if resilience is measured by time and performance is heavily impacted by governance, so the idea of discussing a good governance and incorporating a resilience plan, it's acute for all ports. It became not just like the cherry on top of the cake. Oh yeah, by the way, we have a resilience a plan here. It became a necessity. It became a must-have. And as we know in management, any must-have in an organization has to be part of the strategic planning. So my very final takeaway message here to you is that governance sometimes brings about a lot of discussions in how flexible an organization can be with so much rules and so much process in place. And if resilience is measured in time, at one point, these two things sound like they're going to be conflicting, right? So flexibility, it's actually the name of the game here that ports have to play now more than ever. Thank you very much for your time.
Hello, my name is Paul Mario Kula. I'm a professor of practice at the Ocean Engineering Department at Texas A&M University, posted at Galveston. And I'm going to talk to you today about an engineering perspective on maritime supply chain resilience. So if you look at the definition, dictionary definition of resilience, it is the capacity to recover quickly from difficulties. From an engineering perspective, a system is resilient if it can adjust prior to or following events due to any disturbance or opportunities, thereby sustaining the required operations both in expected and unexpected conditions. And so the responses to both disturbances and opportunities, you could look at COVID as an opportunity for protective equipment. New supply chains have been created, and so you could look at it in a positive sense also. So what is maritime supply chain? So if you really look at it at the highest level, it's a socio-technical system. And what we mean by that is that there are human operators, there's technology, and then there's organizations involved. So it's a kind of complex system. And in today's global economy, organizations work together in networks instead of competing as isolated entities. And so these systems are exposed to various natural, like hurricanes, and man-made, like cyber threats. So resilience is what empowers proactive response to changing market demand and disruption. Currently, the focus is more on operations and has not incorporated too much the voice of the customer, and Lam and Bai's work on that. I will present a little bit more. We'll show you that things are changing. There's research going on this stuff. So here's a picture of the marine traffic, the connectivity across the globe. You can see the shipping traffic. And this is the kind of network that we are trying to execute efficiently. Now what happens is that this is the new complex system of systems network. This is the new norm, but it's like a spaghetti, as what David Woods from the Ohio State University says. It's a tangled, layered network. So if you were to kind of break this down a little bit and look at the 4 senses of resilience, as Dr. Woods says, you could look at simpler systems, not really simple, but you could consider them simpler, and then we'll see some systems there. And rebound from shock, that is one of the, you could think of it as properties of resilience. Robustness is another kind of feature of resilience, and I'll show you an example of that when there are modeled disruptions. When we know a priori what kind of things could go wrong, then we could actually build robustness into the system. But if you step back, like I showed you earlier, these systems are really very complex adaptive systems. And we would look at graceful extensibility, that is the capacity or the capability to stretch beyond the boundaries. So the boundaries beyond which it is designed for. And you could then think about sustained adaptability to cycles of change, things that are changing all the time. So your architecture that you started with in your original design might not be fully applicable, but we want to make a generic architecture that can scale to different changes. And so the goal is to build and sustain systems with an adaptive capacity. So here's the example of robustness. So let's look at the oil supply chain, and let's look at a dynamic positioning vessel. That's a ship that is drilling. And this is supposed to keep its position to kind of drill. And so in this case, we connect it to satellites, and then there's a cyber attack. So when there's a cyber attack, which is not expected, then you want to make the system more robust. And so normally what we do is we have a multiple batch of satellites, that is the GPS system and the GLONASS and multiple position keeping systems, but hackers who are in that domain can hack it easier. So then we actually put transponders underwater, and that's a different kind of system. It makes life more difficult for the hacker. So that is how you make the system more robust. And this is called sensor fusion. And sensor fusion is what enables robustness in this specific case. And so I kind of explain this as a simpler system, even though it is very, very complex. But if you actually look at the bigger picture, then you will see that the work again from Lam and Bai talk about customer requirements of fast service, hassle-free shipment, real-time shipment, and so on and so forth. And so these customer requirements is what we need to meet. And the risks are external risks like the disaster and the terrorism and all this kind of stuff, or supply chain risks like congestion in ports, technical downtime, and stuff. But eventually, you want to take the customer requirements and look at the risks and then map it to resilience measures. And those resilience measures are contingency plans, forecast accuracy, and alliances between different members, and so on and so forth. And if you were to look at it, one potential solution or a better architecture could be the QFD is the quality function deployment methodology as described by Lam and Bai, where you take the customer requirements and then map it to the maritime risks through a relationship matrix. And then you take the maritime risks and then map it to the resiliency measures through another matrix. And I'm not going to go into details of this. You can look at that paper that is listed there. But this is another way of looking at building a better architecture to understand the entire system. And so the nature of modern business is the pressure to do faster, better, and cheaper. And so we do diligent engineering, which is this robust systems like what I talked about. You pre-engineer them, or you have to then, at the bigger level, at the complex adaptive level, you have to look at integrated systems engineering. And so that's where the architectures come about, which are scalable and can respond. And the capability to respond to surprise comes about by these architectures. And so we can adapt to both the disturbances and the opportunities like we talked about COVID. So no plan survives first contact with a disaster in the making. And so you've all heard about this term SNAFU, which is a military acronym, which I'm not going to read out. And so in summary, the maritime supply chains are complex adaptive systems. There is no way to design for unknown possibilities. Machines and artificial intelligence cannot predict the unknown unknowns. So the best way is to train people to adapt to these new situations. And so resilient systems will generally have machines that will automate routine tasks. Plus, we have to have humans who will adapt at the boundaries outside the design spec. And so that is where the architecture comes in and helps to make that happen. And so the goal is to have continuous improvement, cooperate, learn, and adapt. So that's my speech. Thank you.
Okay, hello everyone. My name is Amir Garagazli. I'm from David Nazarian College of Business and Economics, and today I'm going to talk about blockchain in maritime supply chain. More specifically, we are going to talk about benefits, challenges, limitations, and I will try my best to connect it to maritime risk. Okay. I think because you are here, all of you know that maritime trade consists of 80% of global trade by volume and 70% of world trade by value. So we are talking about a huge amount of trade which happens on the oceans. If you want to know a little bit more about maritime supply chain, this is more specifically about containers, but bulk cargo more or less is the same. So we produce something, we put them in containers somewhere in the country because containers are cheaper, faster, and more efficient. Then we have trucks, trains, and barges. We move those containers to a seaport. At that seaport, we are going to have ships. We are going to load those ships. Those ships go to another port. We unload them. And finally, we use barges, trains, and also trucks to send the containers to final consignees. This is the global supply chain, and this global supply chain is dealing with a lot of challenges. For example, we cannot efficiently and effectively integrate national and international ecosystems, ecosystems that we have in China, in the United States, and in Europe. We have lack of transparency and flexibility. We receive all those containers based on a piece of paper, and we trust that piece of paper to receive those containers. And because of these two issues, we are going to have a lot of operational problems. For example, shipping time is very long. We don't have that much service level. Service level is going down. And we are using our resources very inefficiently. And that is going to result in higher costs. So one solution that we can use in order to improve such a supply chain is going to be blockchain. Blockchain is going to be a new distributed information technology. So, for example, every piece of data and information that we have is going to be recorded in blocks. Those blocks, they are on a network, and those blocks, they are going to be encrypted. And they are going to have a hash, and that hash is going to have a pointer to all the previous block and all the previous data that we have. So such a system is going, and then every participant that we have on such a system is going to have a copy of those blocks. So if you have someone on that network who is not, we cannot trust and is trying to change one of the blocks, he or she needs to change all the other blocks which are hashed based on the hash that we have. So the security of such a system is really high. And then we have all the participants basically share all the blocks and all the data which is available on such a system. Basically what happens is that we are moving from what we have on the left side, where we have a central authority, to the right side, where all the businesses are connected to each other one by one, and they share data and information. And such a data and information is available to all of them and is real time. Such a system is perfect for a supply chain such as maritime supply chain because we have a lot of parties, like all these parties, and we can see a list of them here, and then they share all sorts of information with each other. Right now, this information is available from one party to another party and is not going to be shared among all of them. So the final consignee doesn't know where the ship is, where the container is, and so on, so he cannot use that information in order to do more efficient planning. Blockchain is going to be to help with that. So here we are going to look at some of the advantages of blockchain. Here, since I do not have time, I want to limit my talk to 6 minutes, up to 10 minutes. I only tell you about what those advantages are. The details, we can talk about them later on, and you can ask questions about me. The first one is going to be reduction in paperwork and associated costs. Right now, what happens is that we need paperwork. And that paperwork needs the approval and stamps of more than 30 people, which means that 15%, up to 50% of the cost of moving a container is going to be paperwork. Blockchain is online, is real time, so it's going to reduce the cost really significantly. At the end, it's going to be around $15. That's the estimation. The second advantage is that reduction in transaction time. So we are doing workflow automation. If we do workflow automation, what happens is that we are going to have less delays because of documentation errors. It's going to be less. Information delays is going to be less. And then also all the other impediments that we have is going to be less. Also, information is getting shared real time, so we do not need to wait for the manager to sign a document. The document needs to move to the second manager and so on. So everything is going to be faster and automated. Third, enhance transaction security. We know that blockchain is traceable, transparent, and immutable. Okay, we need such a thing in the maritime supply chain because right now, if we want to know that the goods are original, we are dependent on a piece of paper that can get lost or tampered with. On blockchain, that cannot happen because all the information is on the network and it's getting shared, and everybody has a copy of that information. So it's not really easy to tamper with such a data. If you want to tamper with such a data, what you need is that you need a lot of computational effort. And that's not easy. It's not doable by private and individual companies. Basically, governments need to do that. And in order to tamper with data, because it needs a lot of energy, electricity, and computational effort. Fourth, optimization in port operations. That's another advantage. If you have information and it's real time and it's shared by everyone, then you can use that in order to resolve all sorts of operational problems. Fifth, a sustainability promotion. I'm going to give you only one example. Blockchain is also a possible application to aid control overboard discharge of waste. Because some ships, they do not follow rules and regulations. If we know that where they are discharging, we can force them to follow those rules and regulations. Also, we can use the data in order to do studies to see what the impact of those discharges is. However, there are all sorts of good advantages related to blockchain, but there are also all sorts of disadvantages and impediments related to blockchain. First of all, cost of implementation. If you want to implement blockchain, you need a lot of IT infrastructure and you need a lot of electricity. And many companies, they are not yet ready for that. So we have to make the companies prepared for that. Second, laws and regulations. Blockchain is a new technology. More or less, it's after 2008 that we have it available. There are not many laws and regulations. Please, for example, look at Bitcoin. IRS now, they have some laws and regulations, but that doesn't mean that's the final laws and regulations. All sorts of new things are coming out for blockchain. Resistant to change. In the maritime supply chain, we have some huge companies, and those huge companies, they do not really want to change. They have been doing what they have been doing in the past 200 years, and they don't want to really change anymore. That's it. Technology challenge. Again, we have blockchain since 2008, and also some protocols and subsystem and mechanisms are getting created for blockchain. So we are not talking about a final technology which is well established. So which means that many giant companies that we have in the maritime supply chain, they are not ready to use such a technologies. The other thing is that whenever we want to adopt something, a new technology, we are going to have a curve like this. First of all, we are going to have some innovators. They are going to implement it. That we are going to have some people who are eager and implement that. But many companies wait until the later stages of that technology in order to implement that. Okay. So right now we are here and we have to encourage maritime companies to implement it. This can be done by telling them about successful blockchain application in other fields. And we can have third parties who are expert in blockchain and they can help those companies in order to implement blockchain. And that was my presentation, very short and concise, but I'm here available to answer any questions that you have. Thank you for your attention.
Oh, someone has a question. Yes, Michael Miller.
I'm wondering, as the blockchain database grows, how does the system handle when that database gets really huge? A lot of maritime networks, military networks, and so forth don't have a lot of bandwidth. So how is that handled in the blockchain?
I think, Joan, may I just jump in here? We have two types of blockchains. Some of them are public blockchains, so everybody can have access to that. And we have private supply chains, which are going to be among a few participants in the supply chain. So I think maritime companies, they are not going to have a public supply chain. They are going to have a private supply chain, which is going to be from the shippers up to consignees. And you are right, blockchains, they are going to grow, databases are going to grow during time. This is happening for like now for Bitcoin. And we know that one of the main problems that we have with Bitcoin is the usage of electricity. So hopefully in the future, companies are going to be with more technological solutions in order to reduce the amount of the electricity they use. But one of the main problems that right now, many environmentalists, they're against blockchain actually because of that. So hopefully in the future, we are going to have new technologies that deal with that. But right now, that's the problem, and you're right about it, that we need a lot of energy to deal with big databases. I hope that I answered that question.
Yes, thank you.
Hey, Mike Walsh here. Can you hear me?
Yes, this is for Paula DeWitt. Paula, I know you're there.
Yes, I'm here.
Okay.
Let's see. What do we learn from recent cyber attacks on operational systems that are changing the way shipping companies are working? That's a really good question. Right now, there's a big push to better educate, first of all, and make aware of the problem, and to involve a lot more of the vendors and third-party suppliers, because a lot of these attacks are not coming directly from the bigger operations, but from something involved, something integrated in with that system. The best way to learn going forward is to step back, I think, and also look at the pattern of attacks. To me, it speaks a lot that we've got 4 ransomware attacks on our big shipping containers. Why are these being targeted? That must be that they're more vulnerable than a lot of the automated systems are. So, short answer to your question, we're doing more training and awareness to make aware that the threat of the criticality. And second of all, we're looking more at the patterns of attacks to determine better what we should be focusing our protection and detection mechanisms on.
There's a question about greater connection between insurance and from DD, let's see. Greater connection between insurance companies and shipping companies regarding the aggressive cybersecurity. So is there a connection? I think, Paula, this is also your area.
Okay, if I understand this question, you're asking maybe, I'm not sure what you mean by greater connection, but perhaps a greater influence in everything. One of the classes I'm teaching at Galveston is marine insurance. Marine insurance traditionally has not covered cyber attacks. So a lot of what's going on, again, in the education and awareness, the traditional notions of the P&I clubs and this other thing going on, they were built on looking for physical incidents and not cyber incidents. So the difference is when you look at the risk in a physical incident, it might only be one of a big number of ships, where a cyber attack can take on several at a time. So that's another issue we have right now is our insurance. And by the way, this isn't just maritime insurance. This isn't just marine law insurance. Is our insurance keeping up with the current threats and how to better protect? Another observation is, and I can't say this for maritime, but I can say about cyber attacks outside of maritime, a lot of the insurance companies don't pay because they will say that the incident occurred because the victim of that incident didn't use reasonable practices. So it all goes back again to training, awareness, protection, detection, risk management, and figuring out then how you get the data that you can assess your risk to know how much insurance coverage you need. So it's both industry and the insurance companies that need to be working on this.
Joan? Okay, there's a question for Paul.
Yeah, I'm here, John. So the question is, I'm just reading it out so that everyone can hear it. In light of COVID, you spoke extensively about resilience, but I would like to understand your views on key drivers for economic recovery. So in the context of COVID you could think of, is like what Len talked about, Black Swan. It's an event that nobody really thought was going to come. And so when it suddenly happens, how do we redo stuff? So there are already shipping lanes and traffic and everything set for certain other products, and those products might not be required when COVID hit. The question is those chains well designed so that you can flexibly alter it to bring in new products. And if it is bulk cargo, we know that that's not a problem, right? Obviously, if there is oil shipping and if oil is going to get stuck, then you cannot put COVID supplies into an oil tanker. So the question is, how flexible have we designed those supply chains? And so when things change, then can you respond to that, rapidly? So that was my thought process when I talked about COVID. Is it totally designed for a particular product so tightly contained like oil, where you cannot have the flexibility, or if you're talking about bulk cargo and stuff like that, where you can easily switch products very easily? And so we just need to have the mix of everything correct is the thought process there. So I don't know, I hope I answered your question, Allison.
Joan, Mike
Yes.
Walsh has had his hand raised.
Okay.
I don't know if he's still.
There he is. Is his the IMO mandate? Is that your question, Mike?
Yes, ma'am.
Okay, he says the IMO has mandated instructions including timelines for executing maritime vessel OT cybersecurity assessments. How are the IMO regulations being recognized under the port-based security programs? Can anyone answer that? Is that Paula, or is Len still here?
I'm here, but I don't have an answer for you, so.
And I apologize. I don't really know either how well that's going. I know that they are out there, but I don't know what their timeline is, so I don't know what the status is.
Okay.
Yeah, if I may, the timeline was targeted at January of 2021. There's there's several 100,000 vessels floating around on the water at any given time. And as those vessels approach ports, the discussion has been we want both the IT and the OT security assessment posturing analysis that allows that, what, as you have said, to defend, detect, and protect these vessels as well as carriers of ransomware or malicious activity as they approach or dock at port-based facilities. That's the impetus. I have not seen nor found a relationship as a handoff where vessels that are approaching any of our ports, of our check boxes and our analysis, have included information if an assessment has been done and what sort of risk scoring has applied to those vessels, both national and international. Thanks.
So, Mike, I'd love to stay in touch with you on this if you're interested, because I too would like to know what the status is.
Yes, ma'am.
Creating a rubric of some sort? Is that what they're doing? Do you know?
Pardon me, ma'am?
Is there a checklist or rubric that the vessel is supposed to come within its security plans? Do they have anything out there? Do you know?
Yes, ma'am. There is governing documentation published by the IMO that provides not only the requirements but the regulations for the maritime community.
All right, thank you. Now we have another question from.
I think Robert Kraft is next.
Yes. He said, excuse me, with the relative speed of the maritime supply chain, how do you build up supply network to increase resilience? For example, it's highly disruptive to reroute shipping to other ports. Can it be done any other way? Is this for you, Amir?
Yes, there is a lot of research going on in this direction. Rerouting ships is only one of them. You can do a lot of things on the water, and you can do a lot of things in container terminals. For example, ships can delay, and if they delay, the way that you stack your containers, they are not the best way. So you are going to have a lot of reshuffling, and that's not resilient, because ships are going to be delayed, and they are going to delay for the next port. So there is a lot of research going on in this direction, and what I want to emphasize that I'm really an advocate of connection between universities and the maritime industry. The connection and the relationship is not as strong as it's ideal. So if we can work together, we can improve it even better. So for example, the academic people, they need more data. They need to talk to people and see what the real problems are so that they can resolve them when they do research. Right now, research is a little bit theory-driven. So if we can get together and talk about real problems, I think research is going to be more applicable to real problems. But rerouting shifts is only one of the solutions, and we have a lot of other solutions that if you read the literature, there are thousands of papers every year which are published in the maritime industry. But I think those papers, they are not getting communicated with the industry people, and we need to do that better.
I would like to ask some of the industry folks if redundancies in the supply chain are even considered, because there's this push for lean and efficiencies and stuff, and if you had redundancies in the supply chain or two supply chains, if that's even being considered by the industry as a solution. Any takers in the industry? Well, I guess that answers my question. Okay. All right, next question.
You've got a question from Ryan further up there that I saw. Ryan Tran.
Oh, I'm sorry. There's one from Captain Moskoff first. And then,
that's what I was doing. Captain David. Okay, do you foresee ships being more vulnerable to blockchain attacks or interferences due to the weaker connectivity issues for ship versus land-based entities having hard wires and fibers? That is a good question. What about the connection on the ship, from the ship to the land, and those from the land have a better connection? Anybody want to take this one?
I mean, in terms of blockchain, and though I don't see any real problems, for example, look at Bitcoin. In the past 10 years or so that we have had Bitcoin, we never had any problem in terms of attacking a user or hacking something. The good thing about blockchain is that you are going to save your data in blocks. And these blocks are going to be hashed, and each hash, which is basically a formula which is by the United States, by NSA or something, is going to have a pointer to the previous block. So every time you have a new block with new data, you are going to have a pointer to previous block. So if I'm a bad guy and I want to hack one of these blocks, I have to hack the whole thing. But that's not going to be even enough, because these blocks are going to have copies, and these copies are going to be saved on the computers of all the stakeholders that we have on this system. So if you change your copy and then tomorrow you go online and you say, hey, this is my copy, all the other people are going to say, no, this is not a good copy. It's a bad copy because we have different copy and we are more than you. So if you want to hack the system, not only you have to change your own copy, you have to also change those copies. So in order to do so, you need a lot of electricity and computational effort, which is not doable by a private company. Basically, you need a power plant. And private companies, they don't have power plants. Only governments have power plants. So then if somebody wants to hack the system, it should be a government. So I don't know, maybe some governments do that, but as of now, individual people cannot do that.
Yes, well, we know there are bad government actors. Okay, so let's Ryan says, have you had any experience with the use of cyber physical test beds in R&D to manage and promote resilience? Who would like to take
I am currently involved in a project funded by the Department of Energy and the College of Engineering at Texas A&M looking at cyber resiliency in our power grid. And it's a multi-year project. I don't remember how many years, but we're looking just at that. We're building a cyber physical test bed, collecting data off of it, analyzing the data, simulating attacks with the whole idea that whatever we're doing isn't just particular to the power grid. We're developing cyber resiliency principles that can go into any highly automated system. So yes, I've had experience. I am not a double E, okay? I'm a computer scientist, so let me be that. The principal investigator is a double E.
I can just add something. So there was a recent Navy hackathon, Fathom 5. They've come to Texas A&M and talked to us. So Fathom 5 has a system that the Navy actually had last couple of weeks back. Actually, there was a hack the machine competition that they'd opened up, and so they have a cyber test bed. So if you're interested,
Yes.
Mm-hmm. Okay, is the increasing use of single windows required for cargo processing as well as port community systems, which is optional, creating additional vulnerabilities in assessing and enhancing supply chain resilience? Who wants to take that one? Single windows for cargo and port community system for that. Is that anyone familiar? I'm not familiar with these systems. Is anyone else?
I'm not sure what single window requirement means. So
I don't know what that means.
If you can explain a little bit more, please.
Michael, please.
Yeah, this is Mike Edgerton. Can you hear me?
Yes.
Yeah. So, single windows now is required for basically we're manifest information, terminal operating systems, a bunch of other systems in the port environment are combined into essentially a single system whereby its intention is to reduce paperwork, basically, so that shippers and agents, cargo agents, can submit this stuff online. It feeds into a bunch of different systems. One of the ways in which that is done is through the use of port community systems, which is essentially a program or application that's a number of different vendors have. But the issue there, I guess, is from my perspective, is looking at when we're looking at supply chain resilience, is this essentially creating a potential either bottleneck or is it creating a potential series of cascading vulnerabilities because you have systems that are in some ways via APIs or whatever, however they're doing it, they're essentially connected to each other one way or the other. So my I guess question is this now an additional vulnerability that was designed to enhance efficiencies but can create greater risk in system resilience? Does that help explain it a little bit? Okay.
Yes.
Yeah, I think you're right. I think they are all good efforts in a good direction. But at the end of the day, I think what I said also in my presentation is that we have domestic systems and we have international systems. So we can have really good systems in a port community that we have in Los Angeles or Houston, but they are not connected. Even if they are connected, they are not connected to China. Even if they are connected to China, they are not connected to Europe. So maybe you have some information and data and you transfer them to your trucking companies and they are in Excel format, and then this other company is in PDF format, and then there's this other company in Word format, and you have to get them all connected. And doing so, it can bring a lot of problems, as you have mentioned in your questions, because maybe I think it happened in COVID-19 that if you use Excel, which is not new Excel, if it is if it is older than 2015, you don't have enough rows. You only have like 50,000 rows, whereas the new Excel files, they have 500,000 rows. So when they were counting the number of people who were sick, they only have 50,000 people, and then suddenly the number jumped. So that was a problem, and such problems happens if you have domestic national communities and they are not well connected. So they are really efforts in good direction, but I'm not sure if we can get them all together and make them work together. So we need more effort in that direction also.
I can take it from a different perspective, Michael. So, any engineering system, if you try to optimize it for super high efficiency, then it'll lose robustness. And so you have to always think about efficiency versus robustness. Biological systems inherently, as biological species, we are inherently robust to environmental changes, whereas engineering systems are intentionally defined to be efficient, to optimize and maximize profit. But when you get a black swan hitting you, then you're so efficient that you cannot divert yourself. So you want to be cautious when you put in governance policies or whatever that is. And I come from both an engineering and a business background. So, you want to kind of weigh that and say that efficiency is not the only design criteria. You want to also make it robust.
Thank you. Yeah, if there's not been a lot of work done on it, I would just offer this might be a right barrier for some research.
Mm-hmm. Definitely. Thank you.
Right. Thank you.
Any other questions? I see that we're going to have a speaker from Fathom 5 at 1:30. So if people are interested in hearing from them, please join the meeting. Anyone else have any questions? Again, we're putting our contact information. I put mine in the chat. And if you want me to direct anything to anyone, I can in the future. If you don't want to do it right now, or you think about it after you've had lunch. Anyone else?
I'm here, Dave Moskoff. I just wanted to thank you for your response. And if you're hearing me, I wanted to more focus on interference of the ship with the land-based entities. If the signal is blocked or interfered with, I was just wondering how long a ship or shipping company could deal with blockchain not taking place aboard a ship that's connected to their company. Can that go on for days and weeks? What would happen there if they were being blocked?
Right now, what we have for Bitcoin is that every 10 minutes, we are going to have a new block. So all the stakeholders, they need to be connected every 10 minutes so that they can have the most updated blocks. But that does not necessarily mean that for the maritime industry, we have to build it that way. Because, for example, for a shipping company that has a ship on the ocean, they don't need updated information every 10 minutes. Maybe every half a day is enough. So if they get disconnected from the base, and then we can get it back after half a day, it should be enough. But I'm not an engineer. I'm not in the design phase. Maybe Paul or Len Waterworth, they can help me here. But I think for designing such a network, we need engineers to get involved and then ask for their opinions.
The only thing I can comment on the blockchain is that, so if you have the delay is very large, like you said, like Amir said, right, half a day, if that is all the time that the ledger has to get updated, it's fine. But if somebody blocks it for more than that, then the ledgers, this particular trail cannot go into the ledger. And so that will cause disruption, at least the way I understand blockchain. So
you're right, yeah.
That's what I thought I heard. It's just that I know we can block ships for days at a time in different ways. And if something happens to the satellite systems, that becomes an issue too. Very unlikely to fiber systems, though.
Yes.
Great, thank you.
Mm-hmm. Yes. All right. Anyone else have any questions? This has been a good discussion, so feel free to jump in.
If you are looking for a really great course, there's this professor at USC. If you search my name and send me an email, I'm going to forward you his contacts. He has frequent workshops and he talks about blockchain. And he's a great professor. And he starts from the fundamental things. And he has like a workshop is like 1 day or 2 days. And you learn a lot of good things about blockchain and Bitcoin. So if you're interested, please send me an email and I will send some information and contacts to you so that maybe you can attend those workshops.
Yes, put your email in the chat so everyone can see it. Amir, Texas A&M has just finished a large report with Texas TTI, which we call Texas Transportation Institute, on blockchain. So that is also available on the website of Texas Transportation Institute. So if anybody's interested in an overview of blockchain and ports, please take a look at that. We participated in that research. Okay, thank you. Okay, I will hand this over to Andrea then.